Space as the introduction to the guide is big, really big. You won't believe how vastly, hugely, mind-bogglingly big it is, and so on. These are the lines from the movie The Hitchhiker's Guide to the Galaxy, released in 2005. Humans have been looking up at the night sky, dazzled and awestruck, for a long time, since October 4th, 1957, when the Union of Soviet Socialist Republics, or USSR, launched Sputnik, the first artificial satellite to orbit Earth. Human beings have been journeying into space. On December 25, 2021, NASA's James Webb Space Telescope, the agency's successor to the famed Hubble Telescope, will launch on a mission to study the first stars and peek further back into the universe's history than ever before. Welcome to Cosmos Observer. In this video, we're discussing the James Webb Space Telescope captured some unknown object in space. A telescope has been defined as an instrument capable of collecting light from the beginning. In general, the more light it gathers, the better the telescope. This is also why, over time, larger and more powerful telescopes have been constructed. A telescope, however, may have a variety of features apart from catching the light, and it all relies on the mirrors utilized. We can perform science and study the cosmos by joining mirrors of various forms and sizes. It's a complex piece of optics at its best, and astronomers are familiar with such objects. The James Webb Space Telescope, or JWST, is a space telescope that focuses on infrared astronomy. The most powerful telescope ever sent into orbit, its substantially increased infrared resolution and sensitivity will allow it to see things that the Hubble Space Telescope can't see because they're too extremely old, far, or dim. This is projected to open up a wide variety of astronomical and cosmological inquiries, including views of the earliest stars and the birth of the first galaxies, and thorough atmospheric characterization of possibly habitable exoplanets. JWST's primary mirror comprises 18 hexagonal gold-plated beryllium mirror segments that together form a 6.5 meter or 21-foot diameter mirror compared to Hubble's 2.4 meters or 7.9 feet. The Webb telescope now has a light-collecting area of around 25 square meters, roughly 6 times that of Hubble. JWST will see in a lower frequency range from long wavelength visible light or red to mid-infrared than Hubble, which observes in the near-ultraviolet, visible and near-infrared spectra. The new James Webb Space Telescope development by the United States Space Agency has passed a key milestone. Engineers are working on calibrating the mirrors so that the James Webb Space Telescope can capture its first pictures more than a week after entering its scheduled orbit. The telescope will undergo a 5-month commissioning period before humans direct it to the edge of the cosmos to see the birth of the first stars. After that, Webb will travel 13.5 billion years back in time to capture infrared light from celestial objects with far more accuracy than ever before, allowing us to study our solar system and other worlds. It's been a month since the launch, and it's been an incredible journey. Engineers believe that the razor-sharp performance is far better than predicted, and that all of Webb's mirrors had to be aligned to fractions of a human hair's width to reach this point. However, the agency advises that there's still a lot of work to be done before the telescope can be considered operational. Alignment is a difficult task that needs a thorough understanding of optics and physics. Essentially, a beam of light must flow through all of the instrument's parts to minimize light loss. FEINBERG, the NASA engineer who oversaw the construction of Webb's optical components, described publishing the first correctly focused image as phenomenal. You can see other stars in the field that are tightly concentrated and all sorts of other intriguing structures in the background, in addition to the stars and the spikes from the star's diffraction. We've done a very detailed analysis of the images we're getting. So far, we're finding that the performance is as good if not better than our most optimistic prediction. The image released a few days ago displays a burning amber-colored star that shoots streams of light into the universe. The star's background is far more interesting than the star itself, with thousands of specks and dots denoting faraway galaxies that had previously been out of reach. Because of the faraway galaxies, Webb's first image is a deep field. These photographs, which focus on small areas of the sky, attempt to capture the universe's furthest objects. The Hubble Space Telescope, Webb's predecessor, focused on deep fields. However, in terms of depth perception, Webb is likely to outperform Hubble. Without seeing an intense field, Webb can look at any place in the sky for 2,000 seconds. This is going to be the future from now on, Freebie added. This is going to be the future from now on. Wherever we are, it's a deep field. We can travel back in time to galaxies and view light as it appeared billions of years ago without breaking a sweat. In contrast, Hubble takes weeks to get some of its most excellent deep field photographs. Webb would do it in hours. Randall Kimball, NASA's Webb Project scientist for integration test and commissioning, stated in an early interview. On the other hand, the two observatories do not picture the cosmos at the same wavelengths. Hubble is an expert in visible and ultraviolet light, whereas Webb is an expert in infrared. According to NASA specialists, the Webb telescope was intended to be up to 100 times more sensitive than Hubble, and that goal was not only fulfilled but exceeded. No other folding mirror telescope has ever been sent into space. As a result, NASA and its partners had to develop completely new technology that had never been flown to space before to make the mission a success. Because of this, the James Webb Space Telescope has been plagued by delays and cost overruns. The work, however, paid off, as the telescope passed all of its crucial commissioning milestones with flying colors. The first scientific photographs are expected in June or July. Until then, NASA is keeping the location of the celestial object that'll be subject of Webb's first scientific analysis a secret.